So today we're going to graph more rational equations, but now these are going to be in a different form. Now the form is when you have am to the x to the m over bn to, or x to the n, and that basically just means you're going to have a function over another function, and this time they can be different sizes. You can have a bigger function on top, a bigger one on the bottom, same on top and bottom. So what you're going to need to do is first of all know how to find your asymptotes. Now the vertical asymptote is still always going to be the bottom set equal to 0 and solve, okay, because the denominator can never be 0. That's where you get your vertical asymptotes from all the time. But now your horizontal asymptotes are different. If you have more x's on top, you have no horizontal asymptote. So an example of that would be like x squared plus 5x plus 3 all over x plus 6. And when I say more x's, I mean the highest exponent of, so we have an x and we have an x squared. So obviously x squared is bigger than x, so there's more x's on top. You have no horizontal asymptote. If you have the same on top and bottom, and that could be x squared plus 5 over x squared plus 6x plus 7. The top doesn't have 2 x's and the bottom have 3 because you have x squared and then another x. You just look at the highest exponent in each. So this one's x squared over x squared. So that would be the same x's on top and bottom. Then it would be the ratio of your leading coefficients. So if this was a 2 and a 3, then it would be y equals 2/3. Okay? And then finally the last one. The last one would be if you have more x's in the denominator. So that could be x plus 4 over x squared minus 6. Again, this goes back to the fact that you have an x on top and an x squared on the bottom. So since there's more x's on the bottom, then your horizontal asymptote would just be y equals 0 every time. Okay? So let's take these in another direction. So we're going to first look at the form, and what you're going to do to find your vertical asymptote is always set the denominator equal to 0. So for this problem, we have x squared plus 1 equals 0. X squared is equal to a -1, so x is equal to plus or minus I. Now here's the thing. I is an imaginary number. So you can't graph a vertical line at an imaginary number, so this does not have any vertical asymptotes. So then you move on to the horizontal asymptote. You look, you have no x's on the top, you have an x squared on the bottom, so this would go to more x's on the bottom. Y is equal to 0. So then you would go graph y equals 0, which is just a horizontal line at the x-axis. And again, I am not going to make you graph these by hand. So now all you have to do is go to y1 of your calculator and you type 4 in parentheses divided by x squared plus 1 in parentheses, numerator in parentheses, denominator in parentheses, and then you press graph, and you're going to get some nice points. Remember to look at second graph, the table, and see if you can find some nice points that would work out good. And then you just copy some of the nice points, and whatever else you have, just kind of sketch it. Okay, but try to hit those nice points so at least your graph looks fairly accurate. Alright, there you go. That's what that graph looks like. You have your horizontal asymptote. There are no vertical asymptotes, so you're good to go. Our next example here. This one, your vertical asymptote, again, you have to set the denominator equal to 0, or if you want, you can actually factor it because you see that that's the difference of 2 squares. So now you can set your denominator equal to 0, and you should see that you have x equals 2 and x equals a -2 for your vertical asymptotes. Yes, you have 2 of them in this example. So you must graph both. So we have a vertical line dashed, of course, at x equals 2 and x equals -2. So then what you're going to have to do for your horizontal asymptote is you have a 3x squared for your highest on top and a 1x squared for your highest on the bottom. So since you have the same number on top and bottom, you need to just use the leading coefficients and reduce, so your horizontal asymptote is y equals 3. So you go to y equals 3 and you graph your horizontal asymptote. Again, the rest, just type it in your calculator. So I would type into y1 my parentheses for the numerator on top, divided by, and then in parentheses for my denominator, and press enter. Get a couple of nice points where you possibly can. And this one's going to look a lot different than some of the other graphs, and that's because you have two different vertical asymptotes. Okay, so that's going to cause this to change a little bit. So you get a couple of good points like we're doing here. And then all you're going to do is swoop. And it just looks like this. Notice how I'm not crossing any of our asymptote lines. And we're good to go. So that, again, just look at the calculator for the graph. Last example. So this is what happens when we have more x's in the numerator. So for our horizontal asymptote, really quick, you have an x squared over x. That's more on top, so you do not have a horizontal asymptote. Vertical asymptote is always set the denominator equal to 0. So you're going to get x equals a -4. That is your vertical asymptote. Now, what you're going to do is, type it in the graphing calculator. You're going to get a couple of good points that you can work with, and the rest just needs to be sketched. So as you sketch this guy, you're going to see that it looks a little bit like this. But I want you to know that if ever you're working with these and you only see one piece, you might want to consider zooming out. Because way to the lower left here, there is another branch that looks just like that. Remember, these are in a way pretty symmetrical. So you're going to want to make sure that if ever you see something, you go zoom out and see if there's more to find. All right? So this is Longo, and I'm out. See you, bye.